Okay, so we're here on Beaver Creek. So we're about 8/10 of a mile further east than what we were looking at last week when we were on Scott Creek. And then recall before that we were on Point Gracia, which is about another 3.5 miles west of there. So we're working our way east here. Again, what we're looking at here is the contact between the Dunkirk Shale and the Hanover Shale. I'm currently standing on the Kellwasser bed, which again is what we're using as our datum. And you can see here's that intervening gray shale interval that we're interested in. And then we come up to the base of the Dunkirk right here. And then black shale beyond. But then right here again is one of those thin black shale beds that are continuing down, you know, they are expanding and coming into this section as we start moving west here. And these are the beds that we're interested in. So I've just drawn up the section here of what we see, and what we're going to do then is measure these sections out here so that we can get a nice measured section before we go in with sampling. One of the things that the Dunkirk is also noted for is fossilized and carbonized wood. So you can see the remnants of this sort of like, they call it like belt strap, or, you know, I'm not entirely sure. I want to say calamites, but I'm not sure that that's accurate for this age. But you can see some of the black of the remnant carbon in there. So this is all plant material that's floated out to sea and eventually sunk. It's been cooked to some degree. A couple more examples where you can see there's more of the carbon still preserved. So there's a nice piece there, and we found another one. It's a little worn, but there's another piece there of carbonized wood in the Dunkirk. Look at this slab of Dunkirk here that's fallen over. So these are all masses of pyrite, and I'm not really sure what they are. In some areas, especially along the lakeshore, they almost seem to have some sort of current alignment to them. I suspect that maybe they're like pyritized algal masses. But again, just another one of the interesting features that you find in the Dunkirk. All right, so we're breaking out the coring tool so we can do some higher resolution sampling. We got permission from the landowner to use it down here, which is great. So all these white X's that you see on the outcrop surface here, that's the horizons where we're going to collect a core with this coring tool here. So this way we can get in past weathered zones. We can get better resolution, better control on where we're actually grabbing these samples. So that's what we're going to get doing here now. Alright, so what we got here that we're using to collect some of these samples, it's a Pomeroy coring tool. It cuts about a little less than an inch diameter core. And so the main plant here is this gas-powered unit. Is basically, if you're familiar with chainsaws, it's the same type of thing that you'd have for a chainsaw. Then off the side comes this this unit here with a barrel assembly on it, and this is a diamond tipped barrel here, so we can cut really hard rocks, you know, limestones, things like that with it. And then what we have here is a water supply that's hooked up to a pump tank. So this is the coolant system. It keeps the core barrel cool, but then it also lubricates it so that we can get decent samples out of this stuff. So we pump this thing up a whole bunch there, and that sends the water down in through here and out through the core barrel. And then we can drill into the side and collect our samples here. And you can come around here and see, this is some of the sampling we've been doing. So it gives us the opportunity to get very precise and high resolution data. So we've gone here and then up through this gray shale section, and then on like 10 centimeter intervals up through the black shale here. So that's a real advantage to being able to use this for us. Next, we'd like to be able to get an actual vertical coring tool that we could set up on top of these rocks and actually cut a vertical core that goes down through the entire thing, so that we have this three-dimensional outcrop to really understand and characterize what's going on, and then translate that to what we see in core, and also provide us with pristine unweathered samples. So that's what we're moving towards. But right now we're using this more portable sidewall coring unit.
So we're collecting a second set of bulk samples. The first set was just upstream, location 1. This is the second set here. We're going to collect 3 bulk samples. One is going to be from the base, just above the top of the tailwasser bed. A second one from this black shale interval here, maybe this sample in fact, it's falling out. And then a third one from the very top just below the Dunkirk. And we'll collect a fair amount of sample that we can then split into multiple subsamples and then look for variance in those subsamples. And that'll show us some variance from this within this location, but we'll also compare that to the samples that we collected in bulk up there. So we'll have a whole set of bulk samples from there, a whole set of bulk samples from here, that we can make comparisons with both within sample variance and within measurement variance as well.
All right, so just like in the last video where we were at Scott Creek and Point Gratiot, this is the Kellwasser bed right here. So again, this is the Frannian-Fomenian boundary, big mass extinction event, a lot of interesting things going on here. We also want to be able to characterize this, so we're actually, since it's thinner, it's only 16 centimeters here, we're going to see if we can cut a vertical core with this tool going down through it so that we can collect the entire length of this particular Kellwasser bed here. So that's what we're going to try and do now. We're recovering the core that I just cut vertically through the Kellwasser bed. You can see we got a little bit more to go down here. But check out this neat piece of carbonized wood that we pulled up through here. So that's pretty neat. And this stuff we actually did, so this is kind of a neat story. We did vitrinite reflectance work on these coaly material versus the disseminated vitrinite that's in the rock, because these rocks have undergone what they call vitrinite suppression. So if you have very hydrogen rich organic material, which is typical of marine algal kerogen, you can get what's called vitrinite reflectance, which means suppression, which means that the reflectance in oil of the vitrinite disseminated isn't as reflective as it should be for a given thermal maturity. So when you're calculating thermal maturity using vitrinite reflectance, you calculate something that's actually lower than what it should be. So one of the things we thought was like, well, then maybe this coaly wood material hasn't been subjected to suppression, since we can sample this coaly material from within the wood and outside of the influence of this hydrogen-rich marine algal kerogen. But what we found is that it would appear as though this wood is to some degree too also subject to vitrinite suppression. So if you were to measure the vitrinite reflectance of these rocks, you'd get a value of probably around like 0.65 to 0.67, like very onset of the oil window. But what these fracture surfaces here, like we talked about last time, these are actually catagenic fractures. So these are from hydrocarbon generation. So we know that this stuff has been buried at least in starting into the oil window. You do get some primary gas generation that comes along with breaking down of kerogen, not just cracking from oil. But we definitely have gotten thermally mature enough that we've generated enough pressure and gas pressure in order to drive these fractures here. So we do know we have vitrinite suppression, and the reflectance values that we measure here at the surface are probably higher than what we're actually getting with the measurements. All right, guys, so I hope you enjoyed those clips from out in the field there. That was actually last week or the week before that we were out there, but I wanted to give you a sort of behind the scenes look at the other side of this project, which has more to do with the sample prep side. So we collect these samples out in the field, we get them all bagged up and labeled, but then we got to bring them back and get them in good enough shape to be run on XRF and any of the other analytical work that we want to do on these things. So there's a number of processes that are involved in this that includes washing the samples, and then we go through a mechanical disaggregation process air drying process after that, and then we get these things bagged up and we're sending them off to Chemostrat, who has agate ball mills that are going to powderize them for us there. So these few clips that are following this here will give you a little bit of insight into that process.
Okay, you're rolling.
We're rolling. We are washing samples here. So we're taking something that used to be mud that turned into a rock, and now we're trying to wash all the mud off of it there so that we don't have sample contamination, because these are all outcrop samples. So we're trying to get them nice and cleaned up, and we're also running them through a sieve for no real good reason, but we are, because we have, I guess it makes it a little bit easier to clean stuff up. And yeah, so that's the first step in the process, is cleaning these things up. Then I'm gonna have to go over and hose all this soapy water. So we're just using Dawn dish detergent, water, brush all the mud and stuff off these things, and then we'll hose them down, clean them up.
Off station.
You can try and capture something embarrassing, but ultimately I can just cut that out.
There's only so much you can cut.
Turn around that way. Welcome to our high-tech hosing off station. Basically, all we're trying to do here is get all the soapy water off these samples.
This is the crushing station here. It's been modified a couple times. We found this hammer to be optimal for crushing, not to smash like this, because when we do that, the samples scatter everywhere. But to take our samples, these are pretty big ones here, and break them into some smaller pieces, and then just kind of rock back and forth. And we're trying to get these samples to a little less than a centimeter or so per piece, because once we get them to that size, we can put them into another grinder to make the finer powder. And so these grind up, and then we'll dry them out.
That's a man that pays attention to detail right there. So I came into possession of all of these envelopes, and so these are actually basically for drill cuttings, but I have, as you can see, many boxes of them, which actually work out perfect for cleaning, disaggregating, and storing these samples temporarily. So I have this sweet setup here with a cup holder. So labeled bag there, funnel in there, and then I can pour the sample down in there and bag these things up so that we can powderize them later and then analyze them. All right, guys, well, I think that's going to do it for this video. Thanks for sticking through and watching all of this and joining along with us on this adventure/research project that we got going on here. I've gotten a lot of positive feedback on the first video, so thanks to everybody that took the time to watch that as well. We did a Zoom kickoff meeting, which I'm just working on editing out some of the stuff on there and blurring out, you know, faces and last names just to protect people's anonymity on there, but I'll get that uploaded as well. And the super exciting news is my coring tool is supposed to arrive today. So if all goes well, I'll have that thing up and running, and if the weather holds and the creeks stay low, we'll be able to get out and cut some vertical cores through these sections here. So I'm really excited about that. Anyways, so long. Thanks again for watching.